Okay, there's something weird that happens that we've been kind of ignoring for a little bit here. We're going to pay attention to it now. When we're using truth tables to symbolize a statement, or when we're looking for equivalent statements, we have to deal with the fact that we have two basic statements that are true in 3 rows. Now, we have the disjunction, the or statement, and that's true, except when both statements are false. But then we also have the conditional, that's the if-then statement, which is true except when the first statement is true and the other is false. If we're symbolizing statements, or if we're looking for an equivalent, how do we decide which one to use? Well, in the past, we've preferred to work with or, because ors are easier to work with than conditionals. If we're looking for an equivalent to a symmetric statement, an and statement, an or statement, an if and only if statement, we look for one that uses or because it's also symmetric. On the other hand, if we started out with a conditional, we might want to look for an equivalent that is also a conditional. At least, unless getting rid of conditionals was our main goal. And we kind of like conditionals because they make a lot of sense in arguments. So these are all kind of, well, I like or because it's easy, or I like conditionals because they show up in arguments, or because I started with a conditional. That doesn't sound like a rule. That just sounds kind of like an aesthetic, right? In fact, we can pick whichever one we want. Even more than that, there are actually 3 statements that we could have here, right? We could have a disjunction where order doesn't matter, or we could have a conditional with P first, or we could have a conditional with Q first. And it turns out that by working carefully with negation, we can actually get any column of 3 trues and a false using any of those connections. So let's look at our truth values here. So for P or Q, we want to look at these 2 columns. This is true as long as there's a true. It's only false when there are 2 falses. So it's false when P and Q are both false. It's true the rest of the time. For not P or Q, we want to look at these 2 columns. And again, the or is going to be false when both of these are false, and true the rest of the time. For P or not Q, we'll want to look at this column and this column. And once again, the or will be false when both of these are false, and true the rest of the time. Finally, when we're looking at not P or not Q, we'll want to look at these 2 columns. And once again, the or will be false when both of those are false, and it's true the rest of the time. Now, I've just gone through that very quickly. You may want to sit down and work a little bit more carefully, oring together the 2 columns and make sure that I didn't just pull a fast one on you. But I'm wanting to go through these relatively quickly and we can get to the punchline. We'll do the same thing with if P then Q. We'll want to look at these 2 columns. The conditional is false when P is true and Q is false. It's true the rest of the time. For if not P then Q, we'll want to look at these 2 columns. We're going to be very careful because these columns are written in the opposite order from where they are in the conditional. to find out where if not P, then Q is false, we want to see where not P is true and Q is false. That's where this is going to be false. And then it's true the rest of the time. If P, then not Q, we want to look at these columns. And again, that's false where P is true and not Q is false. So that's false in this row and true the rest of the time. And finally, for not P, then not Q, we'll look at these two columns, and that'll be false where not P is true and not Q is false. And then it's true the rest of the time. Last one, the conditional in the opposite order. And again, we'll want to be very careful looking at the order. If Q, then P. We'll look at these two columns, and this conditional will be false where Q is true and P is false, and true the rest of the time. For not Q, then P, we'll want to look at these two columns, and not Q, then P is false when not Q is true and P is false. And it's true the rest of the time. For Q, then not P, we'll want to look at these two columns, and this conditional is false when Q is true, but not P is false, and it's true the rest of the time. Finally, not Q, then not P. We'll want to look at these two columns. This conditional is false when not Q is true, but not P is false, and it's true the rest of the time. Okay, so we just did 12 truth tables. Take a deep breath. What was the point of all that? Well, what we notice is in the first truth table, we have a column where the false is in the last row. We also have a column like that in the second truth table and in the third truth table. In the first truth table, we have a column where the false is in the second row. We also have a column like that in the second truth table and in the third truth table. In the first truth table, we have a column where the false is in the third row. We also have one like that in the second truth table and in the third truth table. In the first truth table, we have a column where the false is in the first row. And guess what? We've got one of those in the second truth table, and we've got one of those in the third truth table. We really can pick whichever one of these we want. We have collections of 3 equivalent statements, one pulled from each truth table. The P or Q, that's this first column in the first truth table. That's equivalent to not P, then Q in the second truth table, and it's equivalent to not Q, then P in the third truth table. Not P or Q, that's that second column in our OR truth table. That's equivalent to, well, that's equivalent to if P then Q, which is in the second truth table. And it's equivalent to, in the third truth table, not Q, then not P. P or not Q, that's this third column in the first truth table. That's equivalent to not P, then not Q, which is equivalent to if Q, then P. And the last one, we've got not P or not Q. That was the last one of our columns in our first truth table. Well, that's equivalent to if P then not Q in the second truth table, or in the third truth table, if Q then not P. Okay, well, this is a whole lot of information, isn't it? The next thing we're going to look at about these things is we're going to call our specific attention to some of these specific relationships. We're going to give them names, and that's going to help us remember which one of these entries is equivalent to which.